In this video, we're going to focus on finding the critical numbers of a function. So what are critical numbers? Well, let me give you a visual illustration. So let's say if we have this function f, and it looks like this. Let's call this point A, B, C, D, and E. So notice that at point C we have a local maximum, and we also have a horizontal tangent line. So at f prime of C, it's equal to 0. C is the critical number. And the same is true for D. This time we have not a local maximum, but a local minimum. And at D, the derivative is equal to 0. That is the first derivative. So D and C are both critical numbers. Now, another point that's a critical number is at point E. So notice that we have a cusp. It's not differentiable at this function, but f of E has a value. E exists in the function. But because it's not differentiable, f prime of E does not exist. Nevertheless, E is still a critical number. Now, it's important to know that a function will not exist if there's a 0 in the denominator. So if you have some function, let's say in a fraction format, if you set the numerator equal to 0, you're going to have this situation, a horizontal tangent line. And so you'll get a critical number. But if you set the denominator equal to 0, then it's not differentiable at that point, but it's still a critical number. So let's say if this is equal to f prime of x. If we set the numerator equal to x, x will equal -4. So that's going to be a critical number. If we set the denominator equal to 0, x will equal 3. So these two are both critical numbers. Keep that in mind. Now let's start with this problem. Let's say that f of x is equal to 4x squared plus 8x. Find the critical numbers of the function. So what we need to do is find the first derivative, set it equal to 0, and solve for x. So what's the derivative of 4x squared? Using the constant multiple rule, it's going to be 4 times the derivative of x squared, which is 2x. And the derivative of 8x is going to be 8 times the derivative of x, which is 1. So thus we have 4 times 2x, which is 8x, so 8x plus 8. So we need to set the first derivative equal to 0 and solve for x. So let's factor out an 8. If we do so, we're going to get x plus 1. Dividing both sides by 8, 0 is equal to x plus 1. So x is equal to -1. So this is the critical number of the function. F prime of -1 is equal to 0. Now let's work on another example. Let's say if we have this function, f of x is equal to 2x cubed minus 15x squared plus 36x plus 10. If you want to try this problem, feel free to pause the video. So go ahead and find the first derivative, set it equal to 0, and solve for x. The derivative of 2x cubed is going to be 2 times the derivative of x cubed, which is 3x squared. The derivative of x squared is 2x, and the derivative of x is 1. And the derivative of a constant is 0. So f prime of x is equal to 6x squared. 15 times 2 is 30, and then plus 36. Now we're going to replace f prime of x with 0. And now let's solve for x. So we need to factor this expression. Notice that every coefficient is divisible by 6. So let's take out the GCF, which is 6. 6x squared divided by 6 is x squared. Negative 30x divided by 6 is negative 5x. 36 divided by 6 is 6. So now we need to factor this trinomial. What two numbers multiply to 6 but add to -5? 2 times 3 is 6, but negative 2 plus negative 3 adds up to negative 5. So it's going to be x minus 2 times x minus 3. So now we need to set each factor equal to 0. And so we're going to get two answers, 2 and positive 3. So we have two critical numbers in this particular example. Here's another one that you can try. Let's say that f of x is equal to 4x raised to the 1/3 minus 8x raised to the 4/3 power. Now, let's use the power rule to find the first derivative. So the derivative of x to the 1/3 is going to be 1/3 x, and then it's going to be 1/3 minus 1. Now 1 is the same as 3 over 3, and 1 minus 3 is negative 2. So this is going to be 1/3 x to the negative 2/3 power. And then minus 8 times the derivative of x to the 4/3. So using the power rule, it's 4/3 x raised to the 4 over 3 minus 1, which is 4 over 3 minus 3 over 3, and that becomes 1 over 3. Now, for this particular type of problem, what you need to do right now is take out the GCF. You need to factor it out. So from both terms, what is the greatest common factor? Well, both terms contain a 4 and a 3. So we can take out 4/3. How many x variables can we take out? So let's say if we have x squared plus x to the 5th power. If you have to factor this expression, what would be the GCF of these two terms? It's going to be the lowest of the two numbers, so it's going to be x squared, and you'll get 1 plus x cubed. Now the way you get these numbers is you need to divide. You divide x squared by x squared, that gives you 1. And for the second one, if you take x to the 5th power divided by x squared, that will give you x cubed. Well, we'll need to apply the same principle here. So which of these two exponents is lower in value? Negative 2/3 or 1/3? Compare it on a number line. The numbers on the left are lower than the numbers on the right. So negative numbers are lower than positive numbers on a number line. So we're going to take out x raised to the negative 2/3. Now, if you take this term and divide it by that term, what will it give you? Because they're exactly the same, it's going to be 1. And if you take this term and divide it by that term, what will you get? The 4/3 will cancel, so it's going to leave behind negative 8. And then if you divide x to the 1/3 by x to the minus 2/3, you need to subtract. So it's going to be 1 over 3 minus negative 2 over 3, which is basically 1 over 3 plus 2 over 3, which is 3 over 3. And 3 divided by 3 is 1, so that's simply just x, which works out nicely. So now this x, I'm going to bring it to the bottom so that we can convert the negative exponent into a positive one. And so we now have 4 times 1 minus 8x divided by 3x raised to the 2/3. So that's the first derivative. Now recall that to find a critical number, f prime of c has to equal to 0, or f prime of c does not exist or is equal to 1 over 0. So whenever you have a fraction, to find the horizontal tangent line, or the first critical number, set the numerator equal to 0, and for the critical numbers where it's not differentiable, set the denominator equal to 0. That's what we're going to do in this example, anytime you have a fraction. So if we set the numerator equal to 0, we really don't need to worry about the 4. Because if you divide both sides by 4, 0 over 4 is 0. So we just got to set 1 minus 8x equal to 0. So if we add 8x to both sides, 1 is equal to 8x. And then if we divide by 8, the first critical number is 1 over 8. Now, Let's determine the next critical number. So let's set the denominator equal to 0. So if we divide both sides by 3, 0 divided by 3 is still 0. And so we can clearly see that x has to be 0. If you raise both sides to the 3 over 2, 0 raised to the 3 over 2 is 0. And here the 2's will cancel, the 3's will cancel, so x is equal to 0. So there's two critical numbers for this particular problem, 0 and 1 divided by 8. Here's another example. Let's say f of x is equal to the absolute value of 5x plus 8. Identify the critical numbers in that function. Now, this is just a generic shape for an absolute value function. The absolute value of x looks like this. And the critical number occurs right at the middle because the function is not differentiable at that point. Notice that for this particular function, the slope changes from -1 to +1 instantly. And so you don't know what the slope is at this point. It's not differentiable. So anytime you have an absolute value function, or if the curve changes abruptly, you have a critical number. F prime of c does not exist at that point. Nevertheless, it's still a critical number at that point. And to find it, all you need to do is set the inside equal to 0. And so for this graph, the critical number is x equals 0. So what about the example that we have, the absolute value of 5x plus 8? All we need to do is set 5x plus 8 equal to 0. Subtracting both sides by 8, we have 5x is equal to -8, and then we need to divide by 5. So the critical number is -8 over 5. So if you were to graph that particular function, around -1.6 is where the y value will be equal to 0. And so we have a graph that looks like this. The slope is 5, so it should be rising quickly. So notice that this point is the critical number at x equals -8 over 5. Here's another problem. Let's say that f of x is equal to x times the square root of 9 minus x. Go ahead and find the first derivative and set it equal to 0 and determine the critical numbers. So in this example, to differentiate it, we need to use the product rule. And just as a reminder, the derivative of f times g is going to be the derivative of the first part, f prime, times the second, g, plus the first, f, times the derivative of the second, g prime. So in this case, we could say that f is x and g is the square root of 9 minus x. But before we differentiate it, we need to rewrite it as x times 9 minus x raised to the 1/2. So now let's begin. So the derivative of the first part, x, is 1 times the second plus the first part times the derivative of the second, which is going to be, if you use the power rule and the chain rule, it's going to be 1/2, keep the inside the same, and then subtract the exponent by 1. 1/2 minus 1 is -1/2, and then differentiate the inside function. The derivative of 9 minus x is -1. So now, like before, we need to factor out the GCF. The only thing that we could take out is 9 minus x, and -1/2 is less than 1/2. So the GCF is going to be 9 minus x raised to the -1/2. Now, 1/2 minus -1/2, if you divide those two terms, that's going to be 1/2 plus 1/2, so the first one's going to be 9 minus x raised to the 1, or simply just 9 minus x. And then, if we divide this term by this one, these two will cancel, leaving behind -1/2 x. to make the negative exponent positive, I'm going to move this to the denominator. So on top we have 9 minus x minus 1/2 x. And on the bottom, it's 9 minus x raised to the positive 1/2. So what is negative x minus 1/2? Negative 1 minus 1/2. Negative 1 is the same as negative 2 over 2. And negative 2 minus 1 is negative 3. So it's negative 3 over 2. So right now we have 9 minus 3 over 2x divided by, I'm going to rewrite this back into its radical form, the square root of 9 minus x. Now I want to get rid of this fraction. So what I'm going to do is multiply the top and the bottom by 2. So f prime of x is equal to 9 times 2, which is 18. 3 over 2 times 2 is 3, so this is going to be negative 3x. And on the bottom, 2 times the square root of 9 minus x. Now at this point, we need to set the numerator equal to 0. So 18 minus 3x is equal to 0. Adding 3x to both sides, 18 is equal to 3x. And if we divide by 3, the first critical number, x is equal to 6. Now for the second critical number, we need to set the denominator equal to 0. So if we divide both sides by 2, 0 divided by 2 is 0. And then if we, that should not be a 2, that should be a 0. If we square both sides, 0 squared is 0. And then we need to add x to both sides. So we can see that x is equal to 9. So the critical numbers are 6 and 9. Now let's work on one last problem. Let's say that f of x is equal to sine squared x plus cosine. So we have a trigonometric function. Go ahead and find the first derivative, set it equal to 0, and find all the critical numbers. Now the first thing I'm going to do is rewrite this function, because I'm going to have to use the chain rule on sine squared x. So I'm going to write it like this, sine x squared. So now let's determine the first derivative. Oh, by the way, the function is restricted from 0 to 2 pi, because sine and cosine are periodic functions and they go on forever. So you may want to add that to the problem. So if you want to try it, feel free to pause the video and work on it. Now let's use the chain rule. So I'm going to move the 2 to the front according to the power rule, keep the inside function the same, subtract the exponent by 1, 2 minus 1 is 1, and then take the derivative of the inside function. The derivative of sine is cosine. Now we need to differentiate cosine. The derivative of cosine is negative sine. Now let's set the first derivative equal to 0. And we need to factor the GCF, which is sine. So if we take out sine x, this term divided by that one, the signs will cancel, leaving behind 2 cosine x. And if we take negative sine divided by positive sine, that will give us negative 1. Now we need to set each factor equal to 0. So on the right side, we need to add 1 to both sides. So we can see that 2 cosine x is equal to 1. And then if we divide both sides by 2, cosine x is 1/2. Now, when is sine x equal to 0? Sine of 0 is 0, sine of pi is 0, and sine of 2 pi is 0. However, x does not include 0 or 2 pi, so we need to get rid of those two answers. So we only have one answer in the interval, and that's pi so far. Now, when is cosine positive 1/2? Cosine is positive in quadrants 1 and 4. Cosine 30 is equal to the square root of 3 over 2, but cosine 60 is 1/2. So therefore, x is going to be 60 degrees, which is the same as pi over 3. Pi is 180. 180 over 3 is 60. And in quadrant 4, it's going to be 5 pi over 3, which is 300 degrees. That has a reference angle of 60 in quadrant 4 because 360 minus 300 is 60. So if you need to review your trigonometry, you can look up my new trigonometry playlist. You can find it in my channel, and you can review this stuff if you need to. So these are the answers: pi over 3, pi, and 5 pi over 3, all of which are in this interval. So that's it for this video. Now you know how to find the critical numbers of a function. So find the first derivative, set it equal to 0, and solve for x.